Alright, hello. So today we will be working through a question that involves momentum and potential energy. And it involves two blocks, M1, M2, on a frictionless surface, which are at first connected by a cord and a spring. Once that cord is burnt off, the spring is then released, decompressed, and it pushes M1 and M2 with some velocity, which we will label V1 and V2, and they are going in opposite directions. So the first thing that we want to know is, well, what is V1? Because we are given M1 is equal to 0.62 kilograms, and then we are given M2 is equal to 2.7 kilograms. V2 is equal to 3.2 meters per second, and V1 is not given. Why do we need V1? Well, what we are essentially solving for is how much energy was stored in the compressed spring before the cord was burned. Immediately, we should think of energy conservation. And so there is going to be potential energy and kinetic energy in this system. With kinetic energy, we're going to need to know both velocities, both V1 and V2. This is an easy calculation. First, we note that the whole system starts at rest. So Pi, the initial momentum, will have to be 0. We also know that momentum conservation is fundamental in a closed system. So we can equate Pi, the initial momentum, to the final momentum, Pf. We note that Pi is equal to 0, so 0 is going to be equal m1 v1 plus m2 v2. However, we note that momentum is a vector, and so direction matters. We're going to make left negative, and so m1 v1 is going to be a negative value. Noting this, we can then equate these two by moving m1 v1 to the other side, so we have m1 v1 is equal to m2 v2. Afterwards, solving for v1 is very simple. v1 is equal to m2 v2 over m1. I will now plug this into my calculator. I get a value of 13.935 meters per second. Knowing this, we can now move on to energy storage. So we know that the total energy must be 0. E total equals 0. And the total energy will be equal to the change in potential energy plus the change in kinetic energy. We note that the system starts at rest and then starts gaining kinetic energy, and so kinetic energy is positive, potential energy is negative. We can once again equate these two. Negative Pe is equal to change in kinetic energy. We can now break it into final and initial. So the final potential energy minus the initial potential energy is equal to change in potential energy. For kinetic, same thing, Kf minus Ki. We note that the final potential energy will be 0 because the spring is completely decompressed. There is no potential energy in the spring. And we note that the initial kinetic energy is 0. The system starts at rest. Once we know this, we now note that the initial potential energy, which is what we are solving for, is equal to the final kinetic energy. Now, what is the final kinetic energy? Well, we note that kinetic energy is equal to 1/2 mv squared. So what the final kinetic energy will be is that we will sum the two kinetic energies from m1 and m2 together and get the initial potential energy. Energy does not deal with directions, so we don't need to worry about positive and negative directions. What we know will then be 1/2 m1 v1 squared plus 1/2 m2 v2 squared is going to be equal to the initial potential energy. Plugging this into my calculator, I get a value of 74.03 joules. And this is the final answer, and we have completed the question. Thank you for watching.